Okay, so today we'll see about tree data structure. Okay, let us start from the beginning. Okay. Okay, let us see theory first, then we'll go to the program part. Okay, tree. The data are arranged in such a way. Okay, so first there will be a root node. Okay, and then each root node has two branches. One is left or right. Okay, so they are connected to root node. Okay, and each branch can have further two sub branch, left and right, and so on. So the data are stored as a root node, okay, in the middle, and then in the left child and right child also there will be some data. And further left child and right child will have two branch. Maximum it can have two branch, depending on the types of tree. Okay, so in case of binary tree there will be two branches, and in case of canary, k number of branches can be there in the tree. Okay, so basically we will discuss about binary tree only. So each maximum there will be two branches for each node. Okay, and then each node can contain some data. So already we have seen in the linked list, single linked list, how we contain data. Okay, data part and the address part. Here in the node there will be two address. One is left for the left child and the right child. Okay, example, the real life tree. As water flows from root to leaf. Okay, so similarly we can traverse from root to leaf node. So there are several techniques we can traverse from root to leaf node. So they are called traversal, tree traversal. There are three types: one is in order, one is pre-order, and one is post-order. Okay. So other definition of this tree are root. Root already you know. Okay, so root you will discuss further about why you call it root. Then child node, root node, child node, parent node, then branch, depth or height, leaf node, and non-leaf node. So these are basic key term you will use in tree data structure. Let us see. Yes, this is a example. So basically tree, this is a inverted tree. So you can see there is a root, okay, and then it is further divided. The water come from tree root, okay. Here you can see there are multiple branches. Here you can see there are two sub branches, okay, mainly two sub branches, and each sub branches can have one, two, three sub branches. Okay, so what will go like this from the root to the branch, then through this sub branch, then stem, then leaf. Similarly, in the tree data structure, the first node we call as the root node, and you can see root node doesn't have any parent node. Okay, so if we are going to parent node, let us see its child node. What is its child node? So there are two arrow keys you can see, left side and right side. So they are linked. Okay, just like singly linked list, we have linked through a next reference. Here we will join their children with left link and right link. So these arrows are nothing but the link. So the root node will hold the address of the left child and the right child. So there are two main child, one left child and right child of this. Now if I will call this, what is the parent of this node? So this root to node will be the parent node of this child, left and right child. So now by definition, how do we call a root node? Root node doesn't have any parent node. Parent node will be null. Similarly, what do we call as a leaf node? Okay, leaf node are the nodes which which doesn't have any child, either left child or right child. Okay, so left child will be null and root child will be null. So in that case, that node will be called as a leaf node. On the other case, if any of child is there, suppose any other node in between these root and the leaf node, in between these nodes, if somebody has one child only, then also this is called as non-leaf node. Okay, these are the basic term we will use in the tree data structure. Now come to the real picture. Okay, so now how can we represent the red mark node is called root node. It has two child marked as blue, left and right child, and the leaf node are marked as green color, so they are called leaf nodes. So already I have told leaf node doesn't have, those nodes are marked as green node, green color, that doesn't have any children, like left child is equal to null and right child is null, so that they don't have any child. On the other hand, non-leaf node, here in case the blue nodes are non-leaf nodes, so they have left child and right child, and yes. Now coming to root node. Root node can have only children, right, left child or right child or both, but it doesn't have any parent node. What about non-leaf node? You can see non-leaf node, they have both the parent node and the child node, and leaf node doesn't have any child node but does have their parent node. Okay, so this much is clear. Okay, I think the definition. Now we'll come to know, we'll do some problem and program regarding this tree as well. Okay, why these are this type of data structure, tree type data structure will help programmer or user. Okay, how? And yes, this is obviously a nonlinear data structure. We are not going to details why nonlinear. We will gradually come to know why this is nonlinear data structure. Now think how will it help if data are stored in tree data, like tree data structure. What is the benefit of this? Okay, let it be a exercise to you, and let's go to the basic program. Okay, so there are several types of trees, like binary tree. Already I have seen ternary tree. There will be branches, but they have 3 branches: left, right, and middle. Okay, or child 1, child 2, child 3. They can have 3 branches, so that's a called ternary tree. Similarly, you can have k-nary tree, k number of branches we can have. Now second is the most important one, binary search tree. Why this is called binary search tree? Because it has certain properties that the some tree can call by binary search tree. Okay, all binary tree are not binary search tree, but binary search tree are binary tree because it has 2 children at maximum, or 2 branches it can have. Now balanced tree also is another type of tree. Fibonacci tree, B tree and B plus tree. There are other tree also, a number of trees. Now advanced trees are also there. So let us limit to our work around binary tree and binary search tree. Okay, now let's go to the programming part. So how do you define a node in a tree? So I have defined its class node, and it will contain some data. Let us data will be integer type. It has two further address, one is left and right. So what will be the type of the left and right? That will be your node type. Okay, now let's start how to create a binary search tree. This program is not for the binary tree. Okay, this is for binary search tree. So what are the property of binary search tree? Before that, let us discuss binary search tree. Okay, so this is the example of how do we create a binary search tree from a number of elements. So how to get number of elements? You can go to the console, and you can input the as many as number of elements, key elements, or you can take an array and you will build a tree, binary search tree from this array. Okay, the array will contain the key elements which are of type integer. That's why you will declare a method as public node insert to which tree you want to insert. Okay, so that is a node tree, right? And then what key element? That value will be key. Okay, let us see binary search tree properties. Yes. Now binary search tree properties is, this is first of all, this is a binary tree. What is a binary tree? This at max each node, including root node, will have maximum 2 children, left and right, or child 1, child 2. Okay, this is the first case. This must be a binary tree. Now second, the important thing is, so data are arranged like that the number or the data stored left to the root are smaller than the key element of the root node. Okay, I will give an example, then it will be better. Okay. While writing program, I will do this. Okay. Now number of element. Okay. And what about the right side? Right side, all the elements, whatever the nodes are there, their values must be greater than the value of or the key element of root node. This is the basic property. That's why this is called binary search tree. Now why the term appears as binary search tree? Okay, so let us see. Let us see the example first. Okay, and how to insert the element is, now here, so you are doing this all operation to a binary search tree. Remember that thing. And yes, this is the code how to build a tree. So we will use a insert method. Okay, so this is our method, public node insert tree in key. First of all, it will check if tree is null. Suppose there is no tree is totally empty, it will return. If there is a flag is empty, then it will return true. Okay. So you will check, how to check if tree is equal to null. Simply you have written if tree is equal to null, then you will create a new node and you will give the value key to the data part. Yes, there is a mistake. This will be small small tree data will be key. Okay. The code doesn't stop here. After if, there will be two else if block. Else if tree data is less than key. If the key element we are going to insert, if it is less than the root node data, then it will try to insert in the left side, because already you have discussed the property that all the elements present left side of the root, they will have the lesser value of the they have lesser key value than the root node. Okay, that's why we will insert in the tree dot left, and then the key will be inserted there. Then it will recursively call this function, this method. Okay, then it will find where it will insert the element, where the child will be null. Okay, there it will create a node and it will insert there. Similarly, another else is if tree data is greater than key, if the root node's data is greater than key value, okay, there may be this may be reversed. Okay, if the key is greater than tree of data, if key is greater than tree data, then we will insert the at the right side of the tree, because you already know. So let us modify this. If you like write this, if key is greater than tree dot data, trees are root node, the data is having less value than key is greater than, then you will go to the right side of the tree, right side of the root, and then you try to insert. It will recursively call this insert tree dot right dot key and key dot comma key, then it will find a place, okay, where it will create a child and insert there. Okay, so similarly, if you write this, if key is less than better write root dot data. Okay, then you can say root left. Yes, if key is greater than root data, then you will say the root dot right key. Okay, this is the basic the first thing you have to do with data binary search. You will create a tree first, then yes, obviously, now go to, yes, let us make this as to root. Okay, because we want to insert at the root node. Now we'll check if the root is equal to null, then we'll create a root, then finally, and then this the if else block here, if else block here, then finally what will return, let us return the true of root of the node. Okay, the recursively the tree will be built, and we will call each element in the array one by one, or you can use a loop and you can insert the those key value. Okay, here if else block, this two block will be executing. Else if key is less than equal to root data, then key will go and find root of the left of the root and search for the place where it will insert. Okay, so this thing you can detail, will see next class. Okay, let us try to execute this one. Let us see. So go to our ID and create a separate package, new package, we will call as tree. Don't click this, just finish. Now click on that package, create a new class, BST, suppose BST manage search tree. Okay, finish. Yes, so this will be created. Let us see. Okay, so inside this, for that we have to define our class node int data node left and node right. Now I will call this let us save this, then public static public static return type will be node, because it will return the root node. Okay, then insert. Okay, let us instead of create, let us name this method as insert. Now which node I want to insert? I want to insert element in the to the root of the. Okay. Now first of all, let us root if root. First of all, we will check if root is equal to empty. Okay, so here how do you check root is equal to null? So what will do, if it is empty, you will create a new node, then simply I will use dot operator. You can use get and set method also. Let us try this dot operator. Data will be equal to key. Okay, else what are other case? Else if key is less than suppose less than equal to root dot data. Data. Then I will call a method node temp equals to insert. In which node I will which child? I know key is less than data, so I will left. Okay, I will go to left of the root. How do you go to the left of the root? Left. Root dot left comma key. Okay. Another case, else if key is greater than root of data, then node then insert root dot right comment. Simple. And finally we will return the root. Okay. Okay, fine. So no issue. These are the condition. You can return. Now here I want to insert some elements. So let us take an array. Int 5 elements I want to insert. then I will take 11, 10, 9, 5, 3, 4, 5. Yes. Okay, yes, great. Now I will use a loop for I equal to 0, I less than I dot length I plus plus. Okay, so I have not created a declare any uh, tree node. Okay, so let us I will declare node this tree. Okay, equal to none. So I will insert I will call the insert here tree and a of I. Okay, and suppose I will give this to this value tree value. This will return a node, so I will give this value. Now here we have built a tree and assign this to the tree. Okay, it will call each element one by one. Now we will do this one by one, and we can see. Now I want to display this value. Display this value. What are the values inside the tree? How to display? Okay, we will use certain traversal order. Okay, so let us call a this is inside public inside void display tree. I will call this display method. Okay, so to see what are the elements inside the tree, for that I will call another method if root not equal to null, then I will call system dot out dot print. I will print the root data first. Root data. Then I will go and call this display root of left. I will call this recursive function and I will call this dot right. So time being I am just writing this one. Okay, and let us see what are the okay. So first of all it will print the in display node I will pass the tree. So this is our tree's root node. Okay, and it will check if root node not null. First of all it will print the root data, then it will go to the left child and call this method once again, recursively call. Then it will print the root left child node, then it will call the right child node. Okay, so let us try to run this. If there will, this is the overall method how to create a binary search tree. Okay, so let us run this and this traversal order is called as root, left, then child. Okay, so that is pre-order traversal of this tree node. So we'll see the traversal there will be. Okay, so only one node is coming. Okay, let us debug this and let us see. Okay, before going to further, okay, let me check this one, then I will rectify this one. But how they are calling this method, let us see. You have declared a array of 5 elements, 1 2 3 4 5. Then for each element I am pushing the or the inserting the element inside the tree, this tree, and finally I will try to display this tree. Okay, and then in the insert method, what is the condition I have checked? Okay, first it will check if root is not null. Okay, if it is null, then it will create a root node first, then insert the element. Once again, then if next element, if you will check the root data key element is less than, it will go to the left of the that root and insert the key element. If the key is greater than the root node, then it will go and insert the root child of the tree. Why? Because this is the property of the binary search tree. All the key elements which are at the left branch of the root node, they have the values less than the root node, and the nodes which are lying right side of the branch of the root node, they are having the larger or the greater value than the root node. Okay, so this is how do you write. Then we will see in the next class in further details, and meanwhile let me check once again this code, then I will give the output. Okay.